Yeah, so I'll be telling you how to solve part of the chapter, how to solve identities. So first part I had already explained to you. Now I'm going to explain to you the second part, that is cos A upon 1 plus sin A, right, plus 1 plus sin A upon cos A. And we need to prove that this is equal to twice of sec A. So as I explained to you in the previous video, what happens is that you need to solve the LHS to get RHS or RHS to LHS. Now rule number 1 was to convert everything in terms of sine and cos. This is already in sine and cos, so we go to the second step. And what is the second step? The second step is we will take the LCM. So LCM will be 1 plus sine A into cos A, right? We're going to take this in bracket. And when we take the LCM, this cos A will be multiplied with this cos A. We are going to get cos square A plus 1 plus sin A, and 1 plus sin A, when we cross multiply, we get 1 plus sin A whole square, right? And this is solving the LHS. So cos square A will remain as it is, plus this is A plus B whole square. So we will apply the identity A square plus B square plus 2AB. And denominator we are going to write as it is, that is 1 plus sin A into cos A. So here we know that cos square plus sin square is an identity, and cos square A plus sin square is 1. So we are going to get 1 plus 1 plus 2 sin A divided by 1 plus sin A into cos A. Now 1 plus 1 is going to give us 2, so we get 2 plus 2 sin A upon 1 plus sin A into cos A. So what we can do is we can take 2 common. So we get 2 common 1 plus sin A upon 1 plus sin A into cos A. So this 1 plus sin A gets cancelled. We get 2 upon cos A. And we know that 1 upon cos is sec. So this can be replaced with 1 by cos. And 1 by cos is sec. So we get 2 sec A. And this is what we wanted to prove. So we get a RHS. So this is clear, I hope, that we have solved the LHS and we've got the RHS. Then we go on to the third sum. So in the third one, we are getting tan theta. This is an important, you can mark this, tan theta by 1 minus cot theta plus cot theta upon 1 minus tan theta has to be proved equal to 1 plus sec theta and cos theta. So this is an important question of the textbook. So here I am going to start with the LHS, convert tan into sin by cos, and cot will be converted into cos by sin. Okay, step number 1, what are we doing? We are converting into sin and cos. So cot can be written as cos by sin, and tan can be written as 1 by sin by cos. Second step, I am taking LCM. So sin by cos as it is in the numerator. In the denominator, 1 is actually 1 by 1. So when I take the LCM here, this is going to be sin theta. So this is going to be sin theta minus cos theta plus cos theta upon sin theta. Here when I take the LCM, this is going to be cos theta minus sin theta by cos theta. Now how do we solve this? The lowermost number goes right on top. So sin into sin, this sin gets multiplied with this sin, we get sin square theta. And this number gets multiplied here. So cos into sin minus cos. Plus same way here, this cos will go right on top. We are going to get cos square theta, and this sin and this cos minus sin gets combined, or multiply it. So sine into cos minus sine. Now we are going to solve this by taking the LCM. The LCM will be sine theta cos theta. And this is sine minus cos and this is cos minus sine. Actually, it is the same thing with a difference in the sign. So what happens is the difference between 4 minus 3 and 3 minus 4. What is the difference? This is 1 and this is negative 1. So the magnitude is same, but the sign is different. So how are we going to do this? See, we'll multiply sine square with sine. We will get sine cube. And here the denominator, what is happening? This is cos minus sine and this is sine minus cos. So what we need to do is change this sign. Okay, if it was same, then no need to change the sign. If the sign is different, as we saw here, there is a difference in 3 minus 4 and 4 minus 3. So since the LCM we have taken as sine minus cos, and here the denominator is cos minus sine, I need to change the sign. So this sign will become minus cos square into cos, we will get cos cube. Now this is an identity which you did in the previous class, a cube minus b cube. If you have forgotten, you can write down a cube minus b cube is a minus b, a square plus ab plus b square. So solving this a cube minus b cube, I am going to write a minus b in one bracket. In the second bracket, I will get a square plus ab, that is sine theta cos theta, plus b square, that is cos square theta, upon denominator is going to be sine theta cos theta into sine minus cos, right? We are applying a cube minus b cube identity. Now sine minus cos is getting cancelled. In the numerator we have sine square and cos square, which will be 1. So we are left with 1 plus sine cos upon sine cos. Now to get the answer, you just need to separate the terms. So this is 1 by sine theta cos theta. Okay, this denominator is for both the terms, plus sine theta cos theta upon sine theta cos theta. Okay, so 1 upon sine theta cos theta. So we get sine theta cos theta upon sine theta cos theta. So 1 by sine, we have done this. 1 by sine is cosec and 1 by cos is sec, and sine theta cos theta gets cancelled and we get 1. So kindly mark this question important, and this is how we work out this. So step number 1, we have converted to sine cos. Step number 2, we have taken the LCM. Step number 2, we have applied the identity. And step number 4, we have taken the common thing and cancelled it, right? So I hope you've understood this. And the other questions also we'll be doing similarly. And the next video you can see that how to solve the remaining questions.